Assalamu alaikum students. Welcome to Slate. This is me, Khawaja Yasin. Let's study chemistry. So in the last video, we talked about the chapter of chemical bonding for O-levels. And this is also an important chapter for A-levels as well. But in the last video, we only talked about the ionic bonding, which is the bond between two oppositely charged ions, one from metal, which is cation, and one from non-metal. Today, we're going to talk about the second type of bond, which is covalent bond or covalent bonding. Now, in the ionic bond, it was a bond between oppositely charged ions held together by electrostatic force of attraction due to transference of electron. The word is transference of electron, electron transfer. But what is covalent bonding? When an electron pair is mutually shared between two atoms. I repeat, electron pair. What do we mean? What do we mean by electron pair? Two electrons. And there can be more, so it can be electron pairs as well. So it is mutually shared between two atoms. This time we are not talking about ions. This time these are just atoms. So firstly, hint. Remember, we had a hint in the last topic, ionic bonds, that an ionic bond, an ionic compound can be easily recognized by looking at the composition. If a compound is made of a metal and a non-metal, you need to have a metal and a non-metal. That is an ionic compound. But for covalent compounds, they are made up of both non-metals. The distinction between metals and non-metals are already discussed in our video of periodic table, and that you can see it on our page. So, non-metals. For instance, let's look at the examples. Sodium, it's a metal. Chloride, it's a non-metal. So if it's a metal and a non-metal, this is an ionic compound. Water, H2O. Hydrogen non-metal, oxygen non-metal. So that's also a covalent compound now. So all you need to do is just see what the composition is about. You need to know which are metals, which are non-metals. So I repeat, atoms, electron pair or pairs that we'll discuss in the examples, and both should be non-metals. So now let's look at the examples first. Hydrogen. The electronic configuration is very important to understand. The covalent bonding as well, just like ionic bonding. So we know about hydrogen. One is the atomic number and one is the atomic mass. If atomic number is 1, it means that we just have one electron. So hydrogen. So hydrogen has just one electron. What if, let's see, there's no point of doing that though, but this is another hydrogen. If we do the transference of electron, remember like in the ionic bond, we transferred electron. What do we get here? This becomes H plus and this H minus and this becomes H plus. So there is no point, nothing is left here in this one. There is no point of transferring the electrons here. So in the case of non-metals, we will not transfer electrons. We will not donate electrons. Because who does electron donation? It is the metal. Metals donate electrons and then hence they are cations. And we are not going to discuss ions here. Remember, this is just about atoms. So what do we have here? We will not make ions. We need to have them as atoms. So the first hydrogen, this hydrogen needs one electron. This hydrogen needs another electron. What will we do? In the ionic bonding, we share electron. Electron transferred from here to here. But these will now share electrons. Ionic was about transference. This is about sharing, just like that. Like the Venn diagram. So this is one hydrogen. This is another hydrogen. Hydrogen, hydrogen. This hydrogen will share its dot electron and this hydrogen will share its cross electron. And hydrogen being in group period 1 needs to have 2 electrons to fill its outermost shell. So let's look at this hydrogen. How many electrons do we see? Look at this circle, this very circle. If this is my circle, there are 2 electrons here. So this hydrogen has 2 electrons. Let's look at this hydrogen. Even this hydrogen has 2 electrons. So the shell is filled, hydrogen is stable, but what do we get? We get an H2 molecule. H2 molecule. The electron pairs will also tell us about the bonding, but that we will discuss when we discuss the other examples. So that's what they do. Let's do another example of oxygen. You know that oxygen is O2, but let's see how. That's the electronic configuration of oxygen. So let's draw O. That's the nucleus. Because for oxygen, it's all different in colors. So these are the shells. So now we have 2 oxygens. And there's going to be good news for you. Preferably for covalent bonding. For ionic bonding, remember we made all the shells. The first shell, the second shell, the third shell. Electrons are lost. We remove the third shell. Remember? But for covalent bonding, the practice is, let's do the cross one thing first. So oxygen has 8 electrons, 1, 2 and 6 in the outermost. So oxygen needs 2 electrons. Both the oxygen need 2 electrons. In the ionic bonding, the outermost shell loses electron and they go to the outermost shell. But then we show the innermost shells. But in the covalent bonding, whatever is happening, it's happening in the outermost or valence shells. So for covalent bonding, you can skip the inner shells. All you need to do is to show the bonding to outermost electrons. So what will we do? We will make a Venn diagram. So remember electron pair. Pair means 2 electrons. So this oxygen needs 2 more electrons and even this oxygen needs 2 more electrons. So what are we going to do? These 2 electrons, for instance, they will come and get shared. And likewise, these 2 electrons will also be shared. So this is the dot and cross diagram of an oxygen molecule. Let's count the electrons. How many electrons does this oxygen has? 1, 2, 3, 4, 5, 6, 7, 8. 8 electrons are there in this oxygen. Stability. Let's count about this oxygen. 1, 2, 3, 4, 5, 6, 7, 8. Stability. This is mutual sharing. They are not getting transferred. They are mutually sharing it. And hence we get an O2 molecule. There would be a difference in the bonding of oxygen and hydrogen, which we will discuss after the example of nitrogen. Let's make the electronic configuration of nitrogen. 7 electrons. So nitrogen needs 3 electrons to fill its outermost shell. So from where will those 3 electrons come? From another nitrogen. This nitrogen will share its 3 electrons, and the other nitrogen is also going to share its 3 electrons. Let's see how it works. I repeat, we can ignore the innermost shell. Innermost shell or shells. So a nitrogen has 5 electrons in the outermost shell. 1, 2, 3, 4, 5. And this nitrogen as well. 1, 2, 3, 4, 5. Now let's count the electrons. How many electrons do you see for this nitrogen? 1, 2, 3, 4, 5, 6, 7, 8. Octet is filled, balanced. 1, 2, 3, 4, 5, 6, 7, 8. Remember, dot and cross is very important. You need to show one with dot, the other with cross. So that is very important. So 8 electrons filled. What is the difference in the first 3 examples that we've done? Here we see that only 1 electron pair is being shared for hydrogen. For oxygen, we see 2 electron pairs are being shared. And for nitrogen, 3 electron pairs. So students, what you need to know is, it's an important rule of bonding or bonds. One electron pair is equal to 1 bond. 1 electron pair is equal to 1 bond. So, for oxygen, for hydrogen, how many electron pairs are there? Just 1. So, hydrogen has a single bond. What about oxygen? Oxygen has 2 electron pairs. So, double bond. Nitrogen, 3 electron pairs. So, nitrogen to nitrogen, it's a triple bond. So, the number of electron pairs should be counted. You need to have 8 electrons in the outermost shell, and that's when you make a right and a correct covalent compound. Now, let's do other examples. Fluorine. So now that's fluorine. 9, proton number is 9. So 2 electrons in the innermost shell and 7 in the outermost shell. How many does a fluorine need? 1 more. From where will that come? From another fluorine. And as I said, let's ignore the innermost ones. Let's make another fluorine. Cross, 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 cross. 1 cross and 1 dot. Because it only needed 1 electron. 1 fluorine needed 1 electron. So let's count the electrons. As you can see, 1, 2, 3, 4, 5, 6, 7, 8. 8 electrons, balanced. 1, 2, 3, 4, 5, 6, 7, 8. So what is the bonding of fluorine? Single bond, F2. Now there is a beauty of halogens, which are group 7 elements. They all have 7 electrons in the outermost shell. That we know. We did that in the ionic bonding topic as well. You can see the video and also in the periodic table. And since in covalent compound and covalent bonding, we're only showing the outermost shell. Remember, we're only showing the outermost shell. For instance, if I draw chlorine, I know for chlorine, we have one more shell. For instance, Cl had this way. That's the electronic configuration of chlorine, 3 shells, because third period. But as I said, for ionic compounds, we do not need to, for covalent compounds, no need to show the innermost shells. So what do? Chlorine molecule looks exactly like fluorine, though it has more shells. But all you need to do is show the outermost shells. For instance, iodine. Two, three, 4, 5. 5 shells for iodine. But it's in group 7. So how many electrons in the outermost shell? 7. Let me remove this one. So if I have to show an ionic bonding of iodine, I do not need all those shells. I would just make another iodine molecule. The size, it doesn't matter in the exam. So even iodine looks exactly like chlorine and fluorine. The size does not matter. You can make this as bromine as well. It's in the same group. So the group can have the same covalent bonding. Now let's talk about, so these were just the elements as molecules because they can't exist individually. Nitrogen, oxygen, all halogens. But covalent, these were covalent molecules. Similar covalent molecules. We have dissimilar covalent molecules as well. Or compounds. For example, a very important example, carbon dioxide. So for carbon dioxide, what do we know? Carbon is in group 4 of the periodic table. Therefore, all you need to know is what group it is. If carbon is in group 4, how many electrons in the outermost shell? 1, 2, 3, 4. Oxygen group 6. One, 2, 3, 4, 5, 6. So how many electrons does oxygen need? 2. How many does a carbon need? 4. See? Carbon needs to have 8 electrons, so carbon already has 4. So it needs 4 more electrons. But oxygen only needs 2. So the 2 will come from this carbon. Carbon will share its 2 electrons and oxygen will share its 2 electrons. So this is the carbon-oxygen double bond. So now oxygen has 8 electrons. 1, 2, 3, 4, 5, 6, 7, 8. Perfect. What about carbon? Are we done with carbon? 1, 2, 3, 4, 5, 6. So carbon needs 2 more electrons. From where will that come? From another oxygen molecule. And since we have given oxygen a dot, so even this oxygen will also remain a dot. So dot, 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 and 2 crosses of carbon. So oxygen has a full octet, 8 electrons. And look at this carbon now, 8 electrons. It's a balanced covalent compound. And since there are 2 electron pairs being shared, look at the pairs, 1 pair, 2 pair, first pair, second pair. What happens? This becomes carbon-carbon double bond with oxygen. Carbons double bond with oxygen. So this is how carbon dioxide looks like. Now let's do another one. H2O, which is water. So again, let's do it. Oxygen. Group 6. So how many electrons in the outermost shell? 6. 1, 2, 3, 4, 5, 6. What about hydrogen? First element, just 1 electron. Hydrogen needs 1 electron, oxygen needs 2 electrons. So hydrogen can only share 1 electron, not 2. Remember, it cannot share 2 electrons. So this hydrogen comes here. Shares this electron, and that's what it is all about. Likewise, there's another hydrogen that's going to come here. Share 1 electron with the oxygen. And what do we get? Oxygen has to make 2 bonds, hydrogen has to make 1 bond. So that's a water molecule. With oxygen and hydrogen, single bond. That's how you show the bonding of a water molecule. The oxygen now has 8 electrons, balanced. Hydrogen only needs 2, balanced. So that's what you need to see, students. Ammonia, a very important base, a very important compound in your syllabus. Nitrogen is in group 5, hence 5 electrons in the outermost shell. So how many does a nitrogen need? 3. How many can one hydrogen give? 1. So if this hydrogen will give 1, that's a big one and smaller. Then we need another hydrogen. And we need another hydrogen. Look at this hydrogen, 2 electrons, stable. Look at the nitrogen now, 8 electrons. Nitrogen is also stable. So that's what your goal should be, to complete the octet. That's why the bonding stage takes place, to make them stable. That's how ammonia looks like. But now, let's jump to important examples from organic chemistry. Ethane. C2H6. So let's talk about, in this, whenever you have to make a diagram, an electronic configuration, or show the bonding of organic compounds, made up of carbon or carbon skeleton. This we will be discussing in organic chemistry. So whenever you're talking about an organic compound, what will you do? You will first make a carbon-carbon bond. So how many carbons do we have? 2. Carbon is in group 4, hence 4 electrons. 1, 1, 1, 1. And if this carbon is X, this carbon will also be X. Because carbon, you can say carbon is cross. Hydrogen is dot. You can make that, you can ignore that key. It's completely up to you. This time the bonding is shown by X and X, not X and dot. Now, carbon needs 3 more electrons, and each hydrogen can give carbon that. So this is the electronic configuration of ethane. You see there is a single bond between carbon and carbon because one electron pair is being shared. There is going to be a single bond between this carbon and hydrogen, single between this carbon hydrogen, single between this carbon and hydrogen. Likewise, the same way on the other side. So this is the structure of ethane. Remember, first make the carbon-carbon bond, then you add those hydrogens. Now, why did I say that? That will help you in the second example. Ethene. Ethene is C2H4. Remember, first make carbon-carbon bond. The crosses between two carbons. So carbon has 4 electrons. But this time we have lesser hydrogens. We have 4 hydrogens. So 2 for this one. And 2 for this one. Hydrogens are balanced. Obviously, they have their 2 electrons. But the carbon is not yet stable. Why? 1, 2, 3, 4, 5, 6, 7. 7 electrons. How many does it need? 8. Likewise, this carbon isn't stable either. What will they do? They will share even this electron with each other. So there are 2 electron pairs being shared between the 2 carbon atoms. So what would be the structure like? Double bond. So that's how you do it. Last example for this covalent compound, covalent bonding. Ethanol. Or we can do methanol. Let's do methanol. CH3OH. So we have 1 carbon. Carbon has 3 hydrogens. So we can do, the carbon can get cross, hydrogen can get dot, oxygen can get a round circle. So oxygen can get a round circle. You can even give oxygen a dot and cross. That's completely up to you. That can be repetitive. So carbon needs 4 bonds. How many hydrogens do we have? 3 with this carbon. So carbon is cross, cross, cross. Hydrogens are dot, dot, dot. Let's make an oxygen first. Oxygen is in group 6, hence 6 electrons in the outermost shell. How many does an oxygen need? 2 electrons. But carbon can only give 1 because it is only left with 1 electron. So if we add oxygen here, oxygen will only share 1 electron with the carbon. Oxygen is still left with another 1 electron. And that it will share it with this hydrogen. That's methanol. Okay? You can get ethanol as well. It's slightly similar to this. So this is very important. And from here on, before we talk about the properties of covalent compounds, let me explain you one thing. The concept of valency. Valency is the number of electrons involved in bonding. Or you can say, or the number of bonds that an element makes. So let's look at the group numbers. Let's talk about period 2. So talking about this period, this is group 1, this is group 2, group 3, group 4, group 5, group 6, group 7, group 8. How many electrons? Let's talk about what are the number of valence electrons? 1, 2, 3, 4, 5, 6, 7, 8. These are group numbers. These are the valence electrons. What are the charges like? We talked about that in the ionic bonding lecture. So charges are +1, +2, +3. It has got 1 because it is losing 1 electron. This is losing 2. This is losing 3. Group 5 is gaining 3 electrons. 6 is gaining 2 electrons. 7 is gaining 1 electron. So that's where the concept of valency comes in. By valency, we mean this group 1 will have a valency of 1 because only 1 electron is being involved, and this will only make 1 bond. Group 2 will have a valency of 2 because 2 bonds, 2 electrons. 3, 4. Group 5 will have a valency of 3 because it only gains 3 electrons or make triple bonds, just like nitrogen. Oxygen has 6 electrons, it needs 2 electrons, and it makes a double bond. That's what we did. So valency is 2. Fluorine, chlorine, bromine 1, and obviously noble gases are 0. So from here on, they can give you an example in the exam, and they can ask you to identify the group that an element belongs to. For example, let's make a compound structure. Perfect. So students, all you need to identify is these are hydrogens, so we're not going to talk about that. X, Y, and Z are unknown. Which group does X belong to? This is a covalent compound. We don't see ionic bonding, right? So all of them should be non-metals. So X is making 1, 2, 3, 4 bonds. And look at this X. 1, 2, 3, 4. So which group can make 4 bonds? Group 4. So X belongs to group 4. It can be carbon, it can be silicon. They can give you those examples. Y. Y is making 1 and 2 bonds. Now, when we talk about Y, as I would like to repeat, Y has 2 bonds. So Y belongs to either group 2 or group 6. But had it belonged to group 2, it would have been a metal. And they make ionic compounds. This is a covalent one. So it belongs to group 6. Now Z, likewise, Y even here, it's making 2 bonds. Z is making 1 bond. So Z will be either group 1 or group 7. Obviously not group 1, hence group 7. They can give you any example in the exam to identify which element, which compound it is. That's very easy by understanding this very concept. So now let's talk about the properties of covalent compounds. We have discussed many structures. Properties are very important. Just 2 properties. They exist as liquids and gases, which means they have low melting and boiling point. But why is that so? They will ask you in the exam to define that, to explain it on the basis of structure and bonding, the way we did it in ionic compounds. So we call it a simple covalent molecule. It's a simple covalent molecule. And bonding, weak intermolecular forces. For ionic, it was giant lattice structure and electrostatic force of attraction. For covalent, it's weak intermolecular forces and simple covalent compound, hence liquids and gases. Hence, melting and boiling points are low. Now, after that, the second important property is electrical conduction. Students, when we talk about electrical conduction, they simply do not conduct electricity. They do not conduct electricity. Why? As they don't have free moving electrons. Remember, in covalent, we just closed the free electrons. They cannot move around. So that is why they cannot conduct electricity. In ionic, the electrical conduction was because of the ions. Here, normally, otherwise, it's because of the free moving electrons. But in the case of covalent, no electrical conduction and weak melting and boiling point. So thank you so much for being here with me. In the next video, we are going to talk about the giant covalent structures, which is different than simple covalent ones. We have done simple covalent ones, giant are different. So that's going to be a short lecture. And after that, in the last video of this topic, we will discuss metallic bonding and the relationship between all the bondings. How will you get the exam questions? So thank you so much for being here with me. Allah Hafiz.